Intercepts and turning points. A polynomial of degree n will have at most n x-intercepts and n minus 1 turning points. I want to go back to that problem we just finished. This one here. So the degree of this polynomial is 4. We ended up with 4 zeros. We had a positive and a negative 3, and a positive and negative I squared of 5. However, these were not considered x-intercepts. So we have at most this many zeros, or this many x-intercepts. Look at the previous problem. When we multiplied this, if we multiply all of this out, we would have x times x times x, which would give us an x cubed function. So this is a third degree polynomial. Do you notice how we have 3 zeros or 3 x-intercepts? So that's what that part means. Whatever your degree is, you're going to have at most that many x-intercepts. And you're going to have n minus 1 turning points. Remember what we said earlier, a turning point is where your graph goes from increasing to decreasing, or from decreasing to increasing. It's where the graph turns around, in other words. So your graph will have n minus 1 turning points. So let's look at this first example. Without graphing the function, determine the local behavior of the function by finding the maximum number of x-intercepts and turning points. Well, this is a 10th degree polynomial, right? It's degree 10. That means it will have at most 10 x-intercepts. Can you imagine trying to find all those? At most 10 x-intercepts, and it will have n minus 1, or 9 turning points. Alright, here is our last example for this section. Find each item using this function. What is the end behavior of this graph? Well, let's think about the degree of this particular function. If you want, you could go ahead and multiply everything out. Maybe I can do that on another sheet of paper. So what I'm going to do is multiply these two and multiply these two, and then the answers I'll multiply those two. So we're going to get negative 4x squared minus 12x, and that's x squared. Negative 4x and negative 4x is negative 8x. Negative 4 times negative 4 is a positive 16. Okay, let's multiply all of these. Negative 4x squared times x squared. Negative 4x squared times negative 8x. Negative 4x squared times a positive 16 would be a negative 64x squared. Now multiply negative 12x times all of these. So negative 12x times x squared. Negative 12x times negative 8 is a positive 96x squared, and then negative 12x times 16 is going to be a negative 192. I just like to line up all of my like terms. Negative 4x to the fourth, we have 32 minus 12, so that's negative 20x cubed. If we add these together, we get a positive 32x squared and then minus 192. So if I transfer this back up here, looks something like that. Hopefully you don't have to do that at some point. Right now it's okay if you still need to do that though. So the end behavior, remember, is based on the sign of the leading coefficient and the degree of the polynomial. This is degree 4, which makes us think parabola because it's even, but since it's negative, we know it's flipped over, right? So we know that the end behavior does something like that. That means as x is getting smaller, as x goes to negative infinity, y goes to negative infinity. How about when x goes the other direction? When x goes to positive infinity, what does y do? Y also goes to negative infinity again. I did not mean to put two negatives there. There we go. So that's your end behavior. You can also say down on the left, down on the right. Okay, what is the leading coefficient and the degree of this polynomial? Well, the leading coefficient is -4 and the degree is 4. I want you to see how you can get that without actually multiplying it out. When you get your leading coefficient, it's because you multiply this leading term by this leading term by this leading term. -4x times x squared is how we get our -4x to the 4th. So you could actually come up with this entire answer by just looking at it in the original form. The number of x-intercepts, you will have at most 4. Oop, you can't see where I'm pointing. There we go. At most 4 x-intercepts. And 4 minus 1 or 3 turning points. Now we're supposed to find the x-intercepts. Remember, an x-intercept is where y is 0. So we have 0 is equal to, I'm going to use the original function because we need it to be in factored form. So set them all equal to 0. We're going to divide by -4. So we get x equals 0. Subtract 3. So x equals -3. And add 4. So x equals 4. So our intercepts are the points 0, 0, -3, 0, and 4, 0. So we actually have 3 x-intercepts. Remember, we're going to have at most 4. So we verified that by finding them. Find the y-intercepts. It's really easy to use the multiplied out form of our function, but you could use either form when looking for the y-intercept. This is where x equals 0. So if you remember this, I can just put a 0 everywhere there's an x. If that's 0, that's 0, and that's 0, aren't you just left with -192? So you get y is equal to -192. So your y-intercept is a really small number,